Hi everyone, my name is John Wallen. I teach astronomy at Middle Tennessee State University, and I also direct the Computational and Data Sciences PhD program. Today I wanted to talk about using artificial intelligence tools in the classroom, and specifically how students might take advantage of these to develop study materials rather than just sort of answer questions. So what I wanted to do today is go through just an example of this, and I'll be using two different AIs today. One is Claude, and the other one is ChatGPT. So the reason I'm using Claude instead of just ChatGPT or some other thing is it has a really large memory. So you can upload large documents to it, and it's much more effective for handling bigger projects. The data that we're going to be using is from my Astronomy 1030 class, which was taught in the fall of 2020. So I'm going to just kind of show you the material that is typically here. So if you go into something like I guess we can go into like cosmology. You can see there's all sorts of lecture materials here. There's some video links and things like that. The thing I'm going to focus today on is specifically the videos, because each of my lectures was videotaped or video recorded. I guess I'm old, in the classroom at the time the lecture was given. So I'm going to kind of scroll down, and you can see this is all the things that were done. At MTSU, we automatically record this data and put it into the classroom or on the website for D2L. The reason for this was basically COVID. When we first did this, we wanted to have an availability of all the lecture materials as much as possible for this. And we're using a system called Panopto that basically automatically records my audio and also the things on the screen, so you can go through all of this material. So let me pick a lecture. So I don't know. How about this one? Exploring the Universe. That sounds like a good name for a lecture. Oh, there I am. So I'm going to pause that right away. So in the background, you see the entire lecture is here. We can just go through stuff, and you can see there's lots of materials here and questions. But the thing I want to notice is over here there's detail, there's contents, which is kind of the big marks in the time, and you could go through all of this. And what I'm going to do here is look at the captions. So in addition to recording the audio, it's doing automatic captioning the material. And you can see this is the things I was saying. It's been transcribed and put onto a nice text version. And I'm going to go all the way to the end here, 51 minutes later, and I'm going to hit Shift-click and just kind of copy this material. And then I'm going to go over to Claude and say, can you summarize this? Actually, I'm going to have it outlined first. Can you outline this lecture from the transcript? And I'm going to paste. So I just pasted in 56.57 kilobytes of data, just copied from the transcript. And all we have to do here is wait a few seconds. So it's going through, it's processing everything and tokenizing it, and it's going through stuff. And here is the outline of the lecture that's coming up. So some things about the Hubble's constant, different things I talked about, how the evidence shows that the universe was smaller and denser in the past. So this is not a bad start. This is a good thing to do. And it was, again, I took a large amount of text information and basically made an outline of my lecture. So this is pretty nice. Let's see if we can get a summary of it. Could you... Actually, I should be more positive. Please generate a 3-paragraph summary of the lecture. Again, it's a lot of data, so it's going to take a little bit for this to happen. Oh, voting encouragement. This must have been, I must have been saying something about please go and vote, because it was November approximately last year. So this is kind of a nice little summary of the things I talked about in class. So this is, again, helpful. So let's go for the next obvious thing. So please create a set of 10 multiple choice questions based on the lecture material. These should be medium to hard in difficulty, and cover the topics discussed. Please put the answers at the end. Hopefully, these questions will be similar to what I will see on the exam next week. So it's going through and summarizing things and trying to figure out what the teacher intends to emphasize in this course. And I gave it a longer prompt because I want to, make sure the intent is understood. And again, these are actually okay. So you can see the supernova constant's getting, or the Hubble constant's getting larger. What temperature of the universe 400,000 years after the Big Bang, and the answers are going to be below here, but it was 3,000 degrees. Who first detected cosmic background radiation? And it gives a set of answers down here. So this is good. This is a very helpful thing. We can also have it do some other things, like can you generate, 4 tables of data to help me study this, please. So it's just kind of generating the data. Again, it takes a little bit to do this, but it's starting to put together a little table. And it's kind of nice. It actually just kind of puts together some different information that's helpful. This has been formatted in previous versions when I've tried this, but it's fine as it is. Can you, please create a timeline of discoveries for this lecture. So again, hopefully it's going to come up with a nice little timeline of discoveries. It sort of did this already with the cosmic background radiation measurements and some things about Albert Einstein. So 20th century, Albert Einstein, Alexander Friedman, Hubble, George Gamow. So this is interesting because I'm not actually sure that all of the things listed here were in the lecture. So it's probably drawing on its other information to fill out a few things about it. Great. So another thing I might want to do if I'm a student is look at vocabulary or vocabulary list. So please create a vocabulary list for this lecture. So again, this is going to be pretty helpful. I think it's going to come up with some good definitions. Hubble's constant, Hubble's law, Big Bang theory, dark energy, critical density, plasma, good. Cosmic horizon, steady state theory, very good. This is actually, again, a nice set of things. Maybe I would want more. So let's say I'm add 5 additional definitions. Inflation, neutrino decoupling, interesting. Nucleosynthesis, very nice. Neutrino decoupling is interesting. I would have thought I would have just talked about the decoupling instead of neutrino decoupling. That's typically electron decoupling, but that's still good. And I guess I want to do a couple more things. Please tell me what are some common misconceptions from this lecture, or about this election. About this lecture. and the associated material. The reason I would want to know this is maybe there's things that I would have in the back of my brain that would cause me to get things wrong because I have a misconception that I need to correct. So the first thing is the explosion was not distributed in part of space. It created space. That's really good. The redshift of galaxies is caused by the motion of space. It's actually due to the stretching of galaxies. This is really good. This is actually from a previous lecture. We can use telescopes to see all the way back to the Big Bang, and there's a cosmic horizon that we can't go beyond. That's true. These are not bad materials. So again, there's some slight differences in cosmic background temperatures. Very good. So let's go with are there any images that I should review before the test? So unfortunately it can't generate images, but it can give me a list of things that I could Google or perhaps plug it into ChatGPT. So this is kind of cool. So it's suggesting some things. So let me just take this thing, and again, it can't show me an image in Claude, so I'm going to put this into ChatGPT and say, can you show me an image of this? And I should mention, I'm doing a couple things with ChatGPT. I'm using the commercial version, the $20 a month version, and I'm using image search as a plugin. And I'm using one called Astro Daily, which is a set of astronomy images. So let's see if this will come up with anything. I'm using GPT-4 also, so it's kind of a better engine. So it's using image search to see if it can find something. Yeah, so it's not finding it. So it does have a harder time finding these images. It's going to try Astro Daily and see if it comes up with anything. It does give me an explanation for it, so that's helpful. So I could probably take, so let me just take this text. Let me do this, copy it, and we'll go to the Google. And let's take a look at images. And there's some good images. So this would be the type of things that could potentially show up on the exam. So this is, again, pretty helpful. I think that this could show you some of the possibilities. It certainly isn't everything it could do. You could ask it, create a song to help me remember the key concepts in the lecture. And let's see if it comes up with a song here. It probably will. Twinkle, twinkle, little star. Very nice. Redshift tells us how fast galaxies moving past. This is not terribly good as a song, but it's better than nothing, I guess. So we have to accept the fact that it's not going to write great prose the first time. If we went through some revisions, I'm sure it would get a lot better. Also, I'll just try one other thing. Create a set of flashcards. So again, good flashcards. This could be very helpful. Having these things, people like flashcards sometimes. One other thing I'm going to say is the test is in, I don't know, 7 days. Can you help me make a study schedule? I can probably study about 30 minutes every day, and then 1 hour, let's go 2 hours, the day before the test. And I should say that 30 minutes a day would be fine for a single lecture. There's 5 lectures, so you have to be a little careful about this. You're going to have to do a little more time than that. But I want to get an A. So this is kind of nice because it's scheduling specific things to do. So practice quizzing yourself. If you notice, it's review lecture notes and highlights, make flashcards, study things, review this, draw a timeline of university's history. It's suggesting very specific things to do each day. And again, get a good night's sleep. Always a good idea. Comprehensive review of all the lecture notes and studies. This is a really helpful set of things that students can do. The worry I have about this is that it's very easy to see that the AI has this material mastered, right? And there's a danger to assume that if the AI has the material mastered, then you have the material mastered, the student has the material mastered. You might assume that since it's on a computer somewhere that I already know it. So you have to go through the studying to actually get it from the computer into your brain. This can help organize the material. It can help make you a better student and prepare you for the test, unless you take the actions of doing the next thing. So anyway, that's where I want to end today. I thought that was kind of an interesting demonstration. I didn't quite realize how powerful this was until a few days ago in terms of making study materials. I hope you can use this in your classes as well, and have a really great day. Take care.